Hey you all, this is Dr. Franklin, and this is just a quick video tutorial to help you complete a Pearson correlation R in SPSS. This is going to be really quick. It's not a very involved statistic, but before we get into it, let me go to variable view so that we can orient ourselves to this data set. When we click on variable view, we are given a name column which lists out all of the variable names within our data set. As it relates to this particular data set, we even have itemized breakdowns as it relates to some of the subscale scores that are calculated towards the end of the variable listing. So you see there's some sum scores, some total scores, some BFI extroversion, agreeableness scores, dealing with the big five factors of personality. And this is just good to go to initially to make sure that any variables you are using within your analysis are identified with the appropriate measure and the appropriate scale of measure. Okay. And in this particular example, we are going to be conducting. Hey folks, this is Dr. Franklin, and I'm back again with another quick tutorial for my Sci 335 students, my cyber quantitative method students. And hey folks, it's Dr. Franklin. I'm back again with another video tutorial. This is going to be extremely brief. I am going to orient you to this data set, then talk about how you can calculate a Pearson correlation R coefficient within SPSS. So the first thing that I want to do is go to variable view so that I can orient you to this data set rather quickly. If you go over to the name column, you will see all of the variables for this particular data set listed. The type column indicates whether or not it's numeric, it's string, it's date. You have several options listed there. Width speaks to the whole number that you can, the spaces of whole numbers you can use when you're inputting data. Decimals, it speaks to the decimal places, the number that you would like as it relates to the data you're inputting. Label gives more of a description of the named variable over here. So it may tell you the question that was asked in addition to some instructions. You get values right here. This is where researchers can identify whether or not there are certain categorical numbers that should have certain qualitative meaning. It's also a place where Likert scale responses can be indicated. Here is where you place a number. It could be any number that you're going to use to identify missing data in your data set, because sometimes participants don't answer all of your questions. There is a column section and a line section, which speaks to how the data is aligned in data view. You have your scales of measurement where you can indicate whether your data is nominal or solely categorical, if it's ordinal, or if it's interval ratio. And for interval and ratio, scale identifier is used to indicate those types of variables. For the purpose of the tutorial, we will be calculating some Pearson correlations for the big five factors of personality, which are extroversion, agreeableness, conscientiousness, neuroticism, and openness. If we were to scroll up in variable view, we would see that there's a series of BFI items that are listed, and ultimately those BFI items were scored or calculated in such a way to yield these scaled scores as it relates to different aspects of people's personality. This is just one theory in regard to personality. There are several theories out there as it relates to personality. Okay. So that's a bit about the data set. Okay, that's what's happening in variable view. When we go back to data view, we are back in the place where we can enter data, and we can also select certain cases if we wanted to, and we can go about a series of data analysis. Again, what we're doing in this particular tutorial is a Pearson correlation coefficient. The Pearson correlation coefficient, sometimes called the Pearson product moment correlation coefficient, or simply the Pearson R, determines the strength of the linear relationship between two variables. Some assumptions that you should check for before running the Pearson correlation R is that both variables excuse me, should be measured on interval or ratio scales. If a relationship exists between them, that relationship should be linear. Because the Pearson correlation coefficient is computed using z-scores, both variables should also be normally distributed. If your data do not meet these assumptions, there's other correlations that you can run, such as a Spearman row. All right. So how do you go about running a Pearson correlation R? Well, you go to Analyze or Analysis. You go down to correlate because we're talking about relationships. These are statistics that are specifically speaking to relationships. And when we're exploring relationships, we can't say definitively that a variable is causing another variable to occur. All we're saying is that as one variable increases, the other variable is decreasing, or as one variable is increasing, the other one is increasing, or there is no relationship amongst variables. Okay, click on bivariate. And then this is rather simple, folks. All you do is select all of the variables that you would like to explore. And I'm just going to dump all of these big 5-factor personality variables over, or I'm going to select them and then I'm going to move them over into the variable section. And, I did that just by selecting one, hold down control, select the others, use the arrow to move it over. Pearson correlation coefficients is already selected. These are alternative coefficients that you can use if your data is not normally distributed. Test of significance, if there was a specific direction you were looking to see in regard to these relationships, perhaps negative relationships or positive relationships, you would select one-tailed. If you're open to the relationship being positive or negative, you would select two-tailed. And we're going to make it easy for ourselves, and we're going to select this box right here, which flags significant correlations. So when the correlation table is produced, the variables that have significant relationships will be flagged with an asterisk. So it will let us know that, hey, this relationship is significant because the probability of the relationship being plausible is below 0.05. Okay. There's a few other options that are listed over here. If you want, you can select means and standard deviations. There's cross product deviations and covariances you could select, but I'm not going to select that right now. Click continue, and then we'll just simply click OK. All right. Now we're in the Pearson correlation table. You see that we got means and standard deviations listed here. Mean is a measure of central tendency. It tells you on average where the scores tend to hover for 572 individuals. Standard deviation gives you the average distance that a score is away from the mean. If you scroll down, we have a Pearson correlation R matrix. All right. And when we go to interpret these, we want to look at the variables that are intersecting across row and column. So agreeableness, Pearson correlation, we have 0.129. And this is, in particular, the relationship between agreeableness and extroversion. We have a 0.129. So keep in mind, correlation coefficients can fall anywhere between 0 and 1 in terms of absolute value. If you have a 0 correlation, that means that there is no relationship between the two variables. Generally, from about 0.1 to 0.3, you're talking about small minor relationships. From 0.4 to about 0.7, you're getting that moderate strength in terms of the relationship. And then if you have a 1 as it relates to a Pearson correlation R, then that indicates that it is a strong relationship. Matter of fact, it's a perfect relationship. So here we have a minor relationship here. The absolute value tells us that it's a minor relationship. The positive or negative sign tells us the direction in which these variables are related with each other. There is no positive or negative sign listed here. If it's a positive relationship, it just simply shows nothing. So we can assume that this is a positive relationship. We got 2 asterisks, which down here lets us know that the correlation is significant at the 0.01 level, two-tailed. And it's a positive relationship. So in essence, as agreeableness goes up, extroversion tends to go up as well. Okay. And we have further indication here that the relationship is significant by going to the significant two-tailed column. We see 0.002. And then capitalized N, which is representative of the population. This is for 572 individuals. Now, something to keep in mind is that typically with these types of correlation matrices, you have a series of ones diagonally dividing this correlation matrix. So everything to the right of these ones is basically a repeat of everything that's down here. Okay. And that's pretty much it. So, if you were to put this in a correlation matrix table, you could simply just put a dash here to indicate that, these correlations are basically replicas of here. And you definitely wouldn't indicate the ones because it's assumed that, of course, BFI conscious is going to have a correlation R of 1 with itself because that's a perfect relationship. It's the same thing. So you wouldn't indicate that information. You just focus on one part of the matrix. Let's go to another Pearson correlation R and interpret. We got BFI neuroticism, and its relationship with extroversion is negative. So what that means is as neuroticism goes up, extroversion tends to go down. We see that it's a significant relationship because we got two asterisks. It's significant at the 0.01 level, and we see that it's a small minor relationship. Okay, it's 0.258. So it's approaching a moderate strength relationship, but for the most part, it's a small moderate relationship. Okay, you can use the same logic that I use to interpret that positive correlation and that negative correlation with every other correlation R that you see here in this output. Okay, for the purposes of your assignment, you will be looking at these personality variables, but you'll throw one additional variable in the mix, and that's fear of missing out total. So going back to our data set here, you'll basically go to correlate again, bivariate, and then you'll scroll down. You will add the FOMO total, move that over to here, hit OK, and then you will present a correlation matrix to me in addition to a brief write-up. I hope that this was helpful. If you have any questions, feel free to let me know, and take care.